I guess if it's a coin flip, eventually, with billions of coin flips going per decade, law large number, eventually you'll have. Oh yeah, that's why like.
I thought I was gonna be by myself.
Law
I
large
was like,
numbers. I
oh.
love so damn fun.
Nah, it's okay.
I like the talk.
Yeah. Okay, let's get started. Hello. I'm not Brianna anymore. If you forgot my name, it's Katie. Today we're gonna go over data types and functions. So a lot of new content, and it's a lot of content. So the general vibe, homework 1 was due last week. Homework 2 is due next Tuesday on the 11th. Office hours are also up and running. So if you have any questions or want to yap, we love to yap. Come yap. Yeah, let us know if you can't make any of the office hour times. They should be up on the homepage of B courses. If you can't, then we can either set up an individual meeting or we can change times, whatever you need. And use Ed. It's a good platform if you have any questions. So overview for today, we're going to be going over data and data types first, and then we're going to be doing a demo for that one. It's going to be pretty short, and then intro to functions and functions demo. So kind of a lot. So generally, what is data and why should you care? Data is everywhere in the scientific world. So anything that's STEM related, you're going to have to use data if you want to do literally anything. So a lot of the times you store data as variables. So it's just another way of storing information. And a lot of those variables each have a different type. And certain types of data can be more useful depending on the data that you're collecting. So if you're collecting a lot of numbers, you're going to want to store them as integers instead of like something as a phrase. So for example, some variables are on the bottom. X is listed as 7 and Y is listed as what we call a string, which is just some name. And then capital Z is listed as a list, which is a bunch of numbers that are combined in a really nice, easy way to access. And so all of those have different types, and we call them data types. Again, they're just basically new ways to store data. All of these are a bunch of data types. So like I mentioned before, integers are essentially just numbers. They're whole numbers. Floats are going to be anything that's not a whole number. So think any decimals or any fractions that return a decimal. Strings, like I mentioned before, they have the little quotation marks around them, and it's going to be some sort of phrase. Usually you wouldn't want to store an integer as a string because it makes it a lot harder to access, and you can't do like math with strings like you would with integers. Lists, again, it's another way to store just like generally integers, but you can also store strings in lists. Tuples are another good way of storing it. They're all just kind of like little neat ways of storing a lot of numbers. You can have up to thousands of entries in a list, tuple, or dictionary. And a dictionary is another way to have more organized information in a like compressed type of way. So if you have a lot of lists, or if you have a lot of star names, you can list them under stars, or in this example, cookies. There's multiple types of different cookies. You can have Oreo, chocolate chip, oatmeal, whatever you want, and you can all put it under there, and you can have it separate from other entries. So if you were listing like desserts, you would want cookies separate from cakes. So that's one way that that can be useful. Okay, so that was kind of a lot and kind of fast. So we're going to go over a demo just to make sure that you guys got it. So if you guys could open up VS Code and follow along. Actually, you know what? I'm just going to create the file in VS Code because I'm lazy. Okay, and then let's see. Okay, first of all, do you guys have any questions so far? Or is it pretty clear? Data types are just a bunch of weird, funky ways of storing numbers and words. If I'm going too fast, let me know and I can chill out. So I'm just going to name this one functions and data types. So different variable types. There's a function in Python that allows you to see the type of whatever you want by simply just going type. And then in the parentheses, whatever you want, you can put in there. So you can put 1. And when you run it, I'm going to run it in my normal terminal just because that works better for me. But for everybody, there should be this little button in the top right. In the top right here, where if you press it, it should run it in your terminal here. Yeah, it usually doesn't work for me, so I kind of hate it. That's why I run it in my normal terminal. So you can just go into your folder and run it from there. Lol. Thank you. Yeah, typos are not fun. Did I make another typo? Hold on. And I did not type print. Okay. Yeah, so you can see by putting the type function around the integer 1, my output here is going to be classed as integer. So that applies for everything. So if I do that for something else, like let's say float 0.1, it's going to do the exact same thing. So now it's telling me that I have an integer and a float. So instead of typing out 1 or 0.1 or whatever mathematical function that you have every single time, you can set it equal to a variable. So as we saw before, we could set x equal to 7. And if we use x in any math later, like for example, x plus y, and we should define y as well, we'll do it as 2. We can define x plus y and print it, and it should give us the sum of the two values that we defined earlier. Let's comment these out. So if we run that same file again, it gives me the sum of 9. So assigning variables to numbers, this is just a super basic example, but it can be really powerful, especially for when you're doing repetitive things with functions. You can keep calling the same function and modifying it. Okay, so going back to the types. If we call type of x, actually, we'll comment those out again. If we go back to the type of x and we do the same thing, it should tell us that it's an integer in our terminal. Oh. Print. And in case yours isn't working when you're going back and forth to VS Code in the terminal like I am, make sure you hit Control S so that you're saving your file. Otherwise, it won't update in your actual terminal and you'll just keep getting errors or the same thing as last time. So yeah, when I run x, the type of x, it gives me back integer and not like string or something else. Because that x, Python reads x as the value of that integer since we assigned it. So moving on to other types, there's also a list. So same thing, you can create a list by just doing brackets. So if we have a really simple list, 1, 2, 3, 4, we can assign that to a variable as well. So if you have like a specific star value or like a temperature for a certain day, you can set that date as the variable name. For this one, I'm just going to call it my list. And again, if we want to know the type of my list, we can just print out type again, and it should give us that type is a list. Yeah. So it's going to be the second one right here, and it's going to show us that it's a list. And there is one more. Similarly, if you want to make a dictionary, it's a little bit different because you have to use brackets. But going back to the example I used earlier, I'm going to set cookies as Oreo, if I can type. And we'll do oatmeal this time. And then we'll set another section of this to, I don't know, cake. And we'll do red velvet and chocolate for fun. I'm sorry if anyone's allergic to chocolate. That would suck. And then we're gonna print it out. Type my dictionary. I know this is super repetitive, but I'm just trying to get the point across that you can do it for all of these. And then run it one more time, and it did not like that. It didn't save, that's why. So my last one is gonna be dictionary. And that's super useful because if you're ever analyzing data and you're trying to do math on it and you find out that it's not doing math and instead of getting 5 times 2, you're getting 5 2s, that's probably because it's stored as a string or something like that. Are you guys ready to move on or are you still copying down? Okay, I'll give you guys a second. Are there any questions so far? Okay, so I'm gonna go back to the presentation. If you guys need to see this later, you can either come take a picture of it or this recording will be posted. Okay, so just to reiterate, integers and floats, they're numbers. Integers are whole numbers. They can be negative. Same thing with floats. Floats, anytime you see a decimal, instantly a float. Okay, so how to check the type of an object, we just went over that. We should know the type function super well by now. So you just put type and then parentheses around your object. Okay, so just for clarification, what do you guys think the output of type of that number would be? You guys can just say it or raise your hand, whatever you feel like.
Integer?
Close. Yeah, it would be a float just because of the decimal all the way at the end. It doesn't matter where it is, it would be a float. So just a couple of like math notation syntax for Python. That will be useful for probably the homework. It's just pretty intuitive of what you think it would be. Addition is plus sign, subtraction, minus sign, multiplication is the asterisk, division is the slash, modulus is the percent sign. So that's how many times a number can be divided into it. So if you have 10 divided by 4, 4 can only go into 10 twice without having a remainder. So it's going to return a 2. And similarly, the quotient is going to give you the remainder. So 5 can go into 18 3 times, and then that's only up to 15. So the difference between 15 and 18 is 3. So that's what it returns. And then exponent, instead of it being the little caret, it's going to be 2 asterisks. So as you can see on the right, it's going to be 3 double asterisks 5, and that'll give you 3 raised to the 5th power. Okay. For the type of strings are usually words, like hello world as we experienced before, or go bears. Either type of quotation marks works. It just needs to be consistent. So you can't have just 1 and then 2 on the other side. It'll give you an error because Python doesn't read them as the same, but they technically act the same. You can add 2 strings together. So this doesn't work like normal math. This is going to be 134 plus 34, and it's going to give you 13434 instead of what, 172? I think I did that wrong, but you get the point. Indexing. So this is where things get pretty fun, especially with lists and strings and everything else that you can store a bunch of data in. Instead of having to like print out the entire list and read through all of it, you can just say, okay, I want the first letter of hello world for whatever reason. If you do brackets and then 0, it's going to index it to the first one. Python starts on a 0 index and not a 1 index, meaning that the first letter or first row or column is always going to be starting as 0. So if you're trying to get the first letter or first number in a list and it's giving you the second, it's probably because you're using 1. So same thing, if you want to access something in the middle of hello world, say the 5th entry, in this case, it's going to be the space because you're starting at 0. Even though technically it's the 6th spot, always remember that we start with the 0 index. And same thing with lists. Lists are also a 0 index. Everything in Python is. So calling certain elements is the same thing in a list. So if you want a certain number, so in the first one, it's going to be 0. It's going to give you an input of 1. This comes in really handy with the variables because instead of like typing out the entire list, you could have just typed out my list and then a bracket, and it'll give you the exact same thing. So as you can see, you can do 2 different indices. So you can do starting at 2 and ending right before 5. The end is not inclusive. It'll give you 3, 4, 5. So this is 0, 1, 2, and it'll go until 5. So 2, 3, 4, and it won't include the last one, which is 6. So it only gives you those 3 entries. And then similarly, you can also do negative indexing. So instead of starting positive and going 0, 1, 2, it's going to go backwards. So 1 is 0. And going backwards, -1 would give you an output of 6. You can also modify the elements in a list. So similarly to how we saw you can add strings before, you can append or you can take out. Those all have specific commands that we'll go over later. But just for right now, know that you can modify the elements in a list. Especially you can multiply them. So if you want 3 times the length of your list, you can multiply it by 3. Or if you want to add 2 lists together, you can do it with just the plus symbol. Or like I said, there's a command to do that later. Okay, and for tuples, you can also index and operations all the same as a list, but you can't change the elements, meaning that you can't really change anything in here. So if you wanted to change this 1 to like a 5, you wouldn't be able to do that. You would have to create an entire new tuple, but you can still index it. And as part of this example, I think this is a little bit ahead, but what do you guys think would happen when you run this? So you're telling it to go to the negative index and then 0 index and set it equal to 100. Yeah.
Would it set the green to?
Close. So if it was a list, it would, but in this case, since it's a tuple, you can't change it, and so it would give you back an error because you can't change the tuple at all. Okay, and then dictionary. Dictionary is going to be pretty similar to the list, like I mentioned before. You can modify the contents of a dictionary, I believe. And accessing items looks pretty similar, except instead of indexing it with like a 0 or 1, you're going to put the name of the subset that you want. So in this case, if you want all the list of stars in your dictionary, you're just going to type in stars and it'll return Sirius and sun. Yeah. Okay. So far, any questions? All pretty clear? Okay. So moving on, Booleans are ways of setting things to true or false. So this can be really powerful, especially if you're comparing a lot of information. Like, for example, if you're comparing what politicians got more votes in a certain data set, you would be able to set one of their votes greater than or equal to another vote and be able to see who won. So that's a really like complex example, but basically at the base level, it just tells you if it's true or false. And it's always going to return a value as true unless it's not. So for example, the output of Boolean of just nothing inside it would return true because there's nothing telling Python that it would be false. So some examples of Boolean operations: 3 is greater than 2. I would hope that that would return true. 0 is less than or equal to -100. that would be false. Negative 100 is definitely less than 0. 23, double equal sign to 23. That one's interesting because instead of saying we're assigning 23 to 23, like a variable, like you're assigning x equal to 7, you're testing if those two values are exactly the same. So if one is false and one is true, then they wouldn't be the same. In this case, it is true that 23 is equal to 23, so this would return true. But if you had 23 is equal to 25 in that case, it would return false. Okay, and then 73, exclamation point, equal sign 9. This notation means doesn't equal, so it's not equivalent to 9. So in this case, it would also return false. Okay, so just to go over some quick review, if you think one of these answers is going to give true, give me a thumbs up. If you think it's going to be false, give me a thumbs down. So true and true. Do we think that would return true or false? Thumbs up, thumbs down. Yeah, it would return true because the Python and statement means that both of them need to be true in order for the statement to return true. So if you had true and false, it would return false. Okay, how about true or false? Okay, yeah, it would return true because true or false, as long as one of the statements is true, it's going to return true. It doesn't matter if you have true or false or false or false. As long as there's a single true statement in there, it will return true. Okay, 1 is greater than or equal to 2. Yeah, definitely false. 5 mod 2 is equal to 1. Yeah, it would be false because 5 mod 2, 2 can go into 5 twice. And so 2 is not equal to 1. 2 is not equal to 2, or 1 is equal to 1. So this one would actually be true. Because like I said before, as long as one of them is true, which is 1 is equal to 1, it doesn't matter about any of the other ones. So even if you have 1,000 elements of true, if say the second one, like this one, is true, Python is going to stop there and just return true because it doesn't matter about any of the other ones. As long as it hits a single true, then it'll stop. Okay. Same thing. 2 is not equal to 2, or 1 is equal to 1. Yeah, this one would also be true. 3 divided by 0 or true. So this one would actually be true because even though you can't divide 3 divided by 0, you still have a true statement in there, so it would still be true. And same thing with this one. True or 3 divided by 0 would still give you true. What about false and 3 divided by 0? Yeah, it would also be false. Both of these are false. That's that. Not 2 double equal to 1. So I know I didn't really go over it, but not essentially means that it's the opposite. So even if you have a true statement, you put not true, then that implies that it would be false. So for this one, not 2 equal to 1, what do we think? Yeah, so that one should return true because 2 is not equal to 1, so that'll be false. So not false is true. Okay. That's that for data types and Booleans. Any questions? Still good so far? Cool. Okay, so this is like actual coding now. Yay. So a function is, yeah, pretty much exactly what it sounds like. It takes an input and it outputs something. So like if you think about a toaster, you put a piece of bread in and it gives you out toast every single time, unless you change the input. If you put a bagel in instead, you're going to get out a toasted bagel. It wouldn't just give you a random piece of toasted bread, or at least I would hope not. So the defining statement, that's just for you to give an action that you want the code to do with a name. So essentially that's what you name your function. So as you can see over here, it would be define and then function name. So if you're going to multiply something, you should probably name it something like multiply or mult. You have to be careful with a couple function names like that because Python reads some of them like sum. It'll take sum as an actual function in Python that'll do something and it'll give you an error. But if you name it something else, then it won't. So the input, same thing. It's going to go inside the parentheses in the top right. It's the information that is known. So that would be something that you set your variables as. And sometimes that can be blank or it can have multiple inputs. So you can have x comma y or however many variables that you need inside the function. So the input would essentially be your toast. And then the output, that's the manipulated information after Python does stuff. So whatever, you know, your function is doing on the inside, that's the code that you actually write and want it to do. It's going to return you an output. And you always have to either put return or print at the end of your function because then otherwise it's not going to give you anything and it's just going to keep running and not know where the end is. Okay. So just to have a clearer picture, your defining statement in this case is just DEF. It will always just be DEF. That stands for define. Don't worry about it. You just got to put it there. Function name, in this case, calc, and then dist. And then arguments, dx, dy, right? So your function body, what your function is doing is just taking what? The absolute value, basically. So you're taking the square root and then squaring all the contents inside of it, or like distance, the length function. And then it'll return you your distance between those two values. Okay, so let's practice that with that. We're going to open up VS Code again. This time, we're going to make a function. I'm going to define two variables. I'm going to do x equals 2 and y equals 2. And to write a function again, it's the define statement. And then for this one, I'm going to call it PWR for power. And it's going to take in arguments x and y. And for this one, I'm just going to be lazy and use Python's power function. So I'm going to set another variable. So I'm going to call this one exponent. I'm going to go x double asterisk y. That's the code for raising something to the power. So it's going to raise x to the y power. And then I'm going to want to return exponent. And then outside of the function, I'm going to print PWR xy. So I'm just calling the function back on itself. And I'm going to mute all this. Save it and run it. So yeah, 2 to the second power is going to return 4. So let's just make sure that it works for a bunch of different numbers. We can try 6. Just to make sure that our code is running fine. 64. We can try, I don't know, 239. It's going to be a huge number. Okay, yeah, that lovely old number. So this is a super, super basic idea of how to write a function. Something to note is that when you're coding with other people, you're going to want to have descriptive variable names. Yeah, did you have a question? Doesn't work for yours? Okay. Charlie will help you. But yeah, as I was saying, when you're coding with other people and doing like data projects and whatnot, if you don't have descriptive variable or function names, it's going to be really hard. Like if I just named this P, what the heck does P do? How are they going to know that that stands for power? Unless you make a comment that says that, then it's going to be really hard to tell. So an easy way to do that is to give your function a definition. So if you do 3 little quotation marks, or not quotation marks, apostrophes. 3 apostrophes, you can write a description. So you could say this function take so this function raises the first input to the power of the second input, or whatever you want to put there, so that when somebody is looking at your code and they look at your function, they can go, oh, okay. If you type in PWR xy and put a question mark next to it in your code in a notebook, it'll return to you what that function does with its description. Okay, so those are just two ways to make your code very legible, especially for comments with these little hashtags. Anything that you comment out, your code is not going to recognize this code and it won't run it. So I did that with all the stuff up here too. I still have all of this code. I can just always comment it out. And I'm doing that by pressing Control and the /. So I'm just highlighting it and then Control /, and you can comment all of it out. And your code won't read any of that. So it's a very nifty tool. Yeah, it just makes it a lot more easy for other people to read. And then with your functions, when you're defining variables, these variables are technically global variables, which means that they can't be called, okay, actually, sorry, I said that wrong. Global variables can be called anywhere. So they can be used for your function, and then you don't have to define your function, or they can also be defined inside your function. But as soon as you define, oops, x does not equal y, x equals 2, and y equals 4, right? Let's comment these out. If we do that inside the function, then those are going to be considered local variables. And they can't be called outside. So even if you modify that variable or do anything to it outside of the function, like if I do right here, x equals y minus 2, it won't change it when you run power, because power is only going to know that x equals 2 and y equals 4, and it almost treats those as different variables as outside. So you can't change them and you can't access them unless you're inside the function, or unless you specifically tell Python that x is a global variable. I think that should. And then in which case you can run x equals y minus 2 and it'll actually change the variable, and then that'll change your output of power. So I'm not going to do that one. I just wanted to show you guys that that is a possibility. And in case you're using variables and something's not going right, or you're getting a different output, always check if you defined it beforehand or inside and see how that'll affect your code. So let's see if this one will still run. It should. Nope. So yeah, that's another thing. You're not defining x or y outside of it. So when you're calling print power xy, it can't even read the x or y that are inside the function. So you would have to essentially call power 2, 4 if you want those variables. And now it'll run it again. Does that make sense? Any questions on that?
How do we get the question mark function to return our description?
That one is not going to work in VS Code. I think that might be a function of Jupyter Notebook, which I should have checked before. That one's my fault. But essentially, if you have a notebook, which we'll show you how to do later, if you have a cell and you type in what I wrote there, power xy question mark, it'll return you the description and the function name. So it'll just essentially give you these two bits of information. That's why it's really important, if you don't know what a function does and you're working in a notebook with somebody else or reading somebody else's code, it would be really hard to know. I mean, this one's pretty simple, but when you get into more complicated functions, it's hard to know exactly what it does. So yeah, good question though. Okay, so we can do another function, be very similar. This one, we'll just do multiply equals x times y. Actually, let's use different variables because I'm being a bad coder. You shouldn't keep using the same variables and redefining them over and over and over again, because that gets confusing. So we'll do a times b this time. Okay. So let's see what happens with this function. Oh. Okay. Does anyone want to tell me what happened?
It's saying that like A and B aren't.
Yeah. And also specifically x, because I messed up and I said it should take in variables x and y and return x and y, but I used different variables a and b. So how do you think you would fix that?
Make it all A and B.
Yeah, basically. Okay. So do you think it'll work now? No? Why not?
We still don't know A and B yet.
Yeah. So defining A, I don't know, 24. B, we'll do a really large number because that's fun. Nope. Sorry. Okay, yeah. So it returns both numbers from both functions. 16 and a really large number that I'm too lazy to say. Okay, great. Any questions? Cool. That's basically all I've got. Kind of went through that a little too fast because there's 15 minutes. Is there anything? Okay, yeah, that's pretty much it. You guys can go home.
You go back.
Thanks.
Where are your office?
My office hours are,
Okay.
when are they? Tuesday.
Yeah. Oh.
11. Hold on.
Yeah.
I will start my office hours now.